By the end of this lesson, you should be able to explain focal point and focal length, determine the focal point and focal length of convex lenses, draw ray diagrams to show the position and characteristics of the image formed by a convex lens. Notice that lenses have two basic shapes. Some are thicker in the middle and thinner at the edges. These are convex lenses. Other lenses are thinner in the middle and thicker at the edges. These are concave lenses. What happens to the light when it passes through a convex lens? The light is refracted and converges to a point behind the convex lens. What happens to the light when it passes through a concave lens? The light is refracted and diverges from a point in front of the concave lens. When light passes through a convex lens, the light converges to a point. A convex lens is also called a converging lens. When light passes through a concave lens, the light diverges from a point. A concave lens is known as a diverging lens. The reference line that passes through the middle of the lens is called the principal axis. The optical center of the lens lies on this line. Light rays parallel to the principal axis converge to a point called the focal point or principal focus, F. The distance from the center of the lens to the focal point is called the focal length, F. What can you say about the focal point and the focal length when the lens is thicker? When the lens is thicker, the focal point is nearer and the focal length is shorter. Observe the animation. You will see the three rules of refraction for a convex lens. Consider an object as shown. An incident ray traveling parallel to the principal axis of a converging lens will refract through the lens and travel through the focal point on the opposite side of the lens. An incident ray which passes through the center of the lens will continue in the same direction as when it entered the lens. An incident ray traveling through the focal point on the way to the lens will refract through the lens and travel parallel to the principal axis. The incident rays converge to a point on the opposite side of the lens. This is where the image is formed. 5 incident rays are shown in the animation. Which rays can you complete using the rules of refraction? Using the rules of refraction, the 3 incident rays will meet at a point. This point indicates the image location. What about the other incident rays? The other incident rays must also pass through the point that indicates the image location. Will the location of the image be different for different observers? All observers will see the same image location. In the animation, 5 incident rays were drawn to locate the image. How many rays do we actually need to draw to locate the image? The 3 rays that are the 3 rules of refraction are the easiest to draw. It only takes 2 rays to find the intersection point. The third ray is to check the accuracy of the drawing process. Observe the animation to see how a whole image is formed by a convex lens. Is it necessary to draw all these ray diagrams to determine the image? We only need these two rule rays to determine the image. We can use the third to check. Look at the image formed by the lens. What can you say about the location of the image? Is it situated before or after the lens? The image is situated after the lens. It lies between F and 2F. What type of image is this, real or virtual? The image can be captured on a screen. It is a real image. Compare the size of the image to the original object. Is it diminished or magnified? The image is smaller than the object. It is diminished. What about the orientation of the image? Is it inverted or upright? The image is inverted. Move the object closer to the lens. Determine the characteristics of the image when the object is at the following positions. Note whether the image is situated before or after the lens, real or virtual, reduced or enlarged, and reversed or upright.
The aim of a ray diagram is to determine the location, size, orientation, and type of image formed by a convex lens. An object is further than 2F from a convex lens. Determine the characteristics of the image formed. The image is located at a position between the 2F point and the focal point, F, on the opposite side of the lens. The image is inverted, diminished, and real. Draw similar ray diagrams for an object located at the 2F point and an object located between the 2F point and the focal point F. Compare the images with that of an object located beyond 2F at 2F and between 2F and F. When the object is at 2F, the image is also at 2F. The image formed is real, inverted, and the same size. When the object is between 2F and F, the image is beyond 2F. The image formed is real, inverted, and magnified. When light rays converge to a point after refracting through the lens, a real image is formed. Real images are always inverted. Draw a ray diagram for when the object is located less than F. Will the light rays converge to a point after refracting through the lens? What kind of image is formed? What are its characteristics? When the object is located in front of F, the refracted rays diverge. Refracted rays form a virtual image. The image formed between 2F is upright and magnified. Can an image be formed when the object is at F? When the object is located at the focal point, the refracted rays appear parallel and will meet at infinity. This means that the image formed is at infinity and virtual.